We are the main keen life in the known universe. Envision that we're the main spot where there is knowledge in this world. Space experts all through the world are in awe of this progressive disclosure. The James Webb Space Telescope has captured the subtle gleam of city lights from an incredible 7 trillion miles away from Earth, surpassing all assumptions. This stunning accomplishment does more than simply extend our perspectives as far as what we know about the universe. Hypotheses spin out of control as researchers pore over the information, looking for hints that could unlock the secrets of these distant celestial reference points. The suggestions are amazing evidence that we are not alone in the universe, that the universe teems with life and movement far beyond our comprehension. Is it conceivable that these faraway lights indicate the presence of extraterrestrial societies? What does this mean for our understanding of the probability of life in the universe beyond Earth? Join us as we investigate how the James Webb Telescope has just detected city lights 7 trillion miles away. Launched into space on Christmas Day 2021, the James Webb Space Telescope aims to surpass the well-established Hubble telescope in capturing exceptionally sharp images of newfound celestial objects, planetary systems, and more. A scientific goal of the JWST is to study the formation of the first galaxies by looking into the distant regions of the universe. This is possible due to the fact that light from these galaxies has traveled for billions of years. When the JWST collects light, it observes these objects precisely as they were billions of years ago. Astronomers measure distances in light years, the maximum distance light can travel in a year. To illustrate this reality, the team's initial graphical representation was a profound field image released on July 11, 2022, by U.S. President Joseph Biden from the White House. While the Hubble Space Telescope focused on a single region of the sky for 10 straight days starting on December 18, 1995, the profound fields gained reputation. The selected region was only a tiny spot, making up around 1/1,000,000th of the whole sky. Most of the 3,000 previously unseen objects found by Hubble were galaxies located billions of light-years away. With its focus on the SMACS 0723 galaxy cluster, the JWST's profound field covers a similarly small region of the sky. The galaxy SMACS 0723 is 46 billion light-years away, and the more distant galaxies behind it are amplified by its strong gravitational field. The background galaxies are distorted into massive arcs where the gravitational field is most concentrated. In one instance, it was verified that it took a distant galaxy's light 13.1 billion years to reach the telescope after traveling through space. The light emitted extends as the universe expands. As these galaxies are still so distant, the primary instruments of the JWST have extended visible light from their stars into the infrared. Cosmologists can directly compare JWST's and Hubble's visible light images of neighboring galaxies by gathering data at those frequencies. This will show how galaxies evolve over cosmic time, developing and solidifying into the structures we observe today. Much more astounding than the sheer number of galaxies in the JWST's first profound field image is how rapidly it was captured, in just hours rather than days. Virtually everywhere it looks, it cannot avoid finding galaxies. Galaxy clusters aren't the only objects acting as magnifying lenses. Scientists used the JWST to capture an image of a pair of galaxies designated VV191, so they could study how the light from one of the galaxies changed as it passed through the other. The results of the analysis will reveal the properties of the intervening galaxy's dust. It appears that the JWST may have recently made a notable revelation light-years outside our solar system. The announcement of the potential detection of auroras on a supposed brown dwarf came from the official JWST site. The absence of a host star in the bone-chilling temperature makes it difficult to pinpoint where the energy in the upper atmosphere is coming from. However, the fact that the object is emitting light suggests that auroras are present. Essentially, an aurora on Earth is created when energetic particles that advance into space from the sun are captured by our planet's magnetic field. The charged particles then travel through Earth's atmosphere via lines of magnetic fields near the poles, where they collide with gas particles to produce a beautiful display of light known as the aurora borealis. Jupiter and Saturn have similar auroral phenomena due to the solar wind, but the brown dwarf WISE 0855 has no star to orbit, making its auroras a significant mystery. The hope continues to rest on Proxima Centauri and other nearby stars, just 4.4 light-years from Earth and within the Milky Way galaxy, with scientists identifying the presence of water on the exoplanet. The probability of life on such worlds cannot be ruled out. Are we finally going to see proof of life beyond Earth? Just last month, the JWST discovered another supermassive black hole that was observed in various colors and consumed everything around it. This discovery is 40 million times as large as the Sun. But what does this mean for us? The JWST has found another supermassive black hole that has existed since the beginning of the universe. It may not be good news. This beast is rapidly consuming everything in its vicinity, leading to the discovery by Dr. Lucas Foe and Professor Menade Intelligence Zitron of the Bond College of the An in Israel. According to their revelations, the supermassive black hole is approximately 10 billion times heavier than the Sun, making it a colossal entity compared to the galaxy it resides in. Fortunately, it is not close to Earth or the nearby solar system. It's an incredible 129 billion light-years away. However, it is approaching, with the black hole devouring everything around it at a rapid rate. The reddish hue comes from the fact that it sits in a dense cloud of dust that blocks much of the light from passing through. When the JWST began transmitting its initial data, researchers were excited. Among the data, 3 small AR images with a dark red glow caught our attention. We initially thought it was a quasar-like object, very large black holes at the centers of galaxies that are constantly accumulating material due to their red dot appearance. The entire galaxy's light could not realistically be contained within a spot no bigger than a modern star cluster. We were able to obtain extremely precise size constraints due to the source's gravitational lensing. Even when all the potential stars are compressed into that small region, the black hole still represents at least 1% of the galaxy's total mass. The discovery of such enormous black holes in the early universe has provided insights into the development of both the black hole and its host galaxy, as well as the interaction between the two, which is still largely unknown. Whether very large black holes form from stellar remnants or from early-stage cosmic material falling into black holes remains unclear. Additionally, in the images it transmits back to Earth, the James Webb Space Telescope is discovering other rather peculiar things daily. We have the privilege of exploring space and being captivated by the magnificent lights of planets and stars floating across the universe, light-years away. Moreover, the James Webb Space Telescope allows us to see far beyond what our eyes can detect, such as a question mark in space. For over 20 months, the Webb has been drifting through space, sending back images of its findings in deep space using its advanced near-infrared camera. Now, answers have been provided to the discovery of a rather unusual-looking finding in one Webb image focusing on a different part of space. The image was released by the European Space Agency, showing 2 young stars forming approximately 1,470 light-years from Earth. However, there is a small orange mark at the bottom of the image resembling a flipped question mark. Clearly, the small image is not tiny. In fact, it is exceptionally large. The question mark was captured while observing the pairs of young stars named Herring Legend 46 to 47. They are surrounded by enormous clouds of dust and gas, with the feature being a couple of thousand years old. As for the question mark shape itself, it may appear so due to the two-dimensional image presented by Webb from its specific perspective. As of now, we do not know what it is, and without further research we may never know. However, the discoveries have been reviewed by experts in the field, so it is likely a distant galaxy or possibly galaxies interacting with each other. The distorted question mark structure could be a result of their interactions. Perhaps we have never seen such an object before. To determine its nature with any degree of certainty, further investigation is necessary. With the wealth of distant objects revealed by Webb, there is an overflow of new scientific inquiry. Currently, everyone's attention is focused on a specific set of Earth-sized planets that could hold the potential for finding extraterrestrial life nearby. The Fermi paradox, which highlights the lack of evidence for advanced extraterrestrial life in the universe despite the high likelihood that such beings exist, may finally be resolved. Where are these planets located? Approximately 40 light-years away from Earth and the solar system is a star known as TRAPPIST-1, which has 7 planets orbiting it. In their quest to find habitable planets, NASA considers a multitude of factors beyond planet size and distance from its star. A more effective approach would be to identify the relative concentrations of these compounds in a planet's atmosphere, which would allow researchers to determine whether the planet is habitable. The Infrared Spitzer Space Telescope, which is part of NASA's space exploration mission, previously discovered the 7 rocky exoplanets orbiting the same star known as TRAPPIST-1. The James Webb Space Telescope has now measured the temperature of TRAPPIST-1b, one of those planets. The JWST has consistently delivered significant discoveries since its launch, and this revelation is undoubtedly the latest in a series of groundbreaking firsts. This is the first detection of any type of light emitted by an exoplanet as small and cool as rocky planets in our solar system. No previous telescopes have been able to measure such faint mid-infrared light. Cosmologists were thrilled when they first learned about the 7 TRAPPIST-1 exoplanets, since these distant worlds are all Earth-sized and lie within the habitable zone, the region where planets can have liquid water on their surfaces at the optimal distance from their star. They call the system an exceptional research center and say it is potentially one of the best places to study rocky planet atmospheres. Don't get too excited about another world for humans yet, though. The TRAPPIST-1 planets are currently out of our reach, at an incredible 235 trillion miles away. They are also orbiting a star much smaller and redder than our Sun, known as an M-dwarf star. These stars are much more common in the Milky Way galaxy than Sun-like stars and have double the likelihood of having rocky planets compared to Sun-like stars. These large M-dwarfs are ideal targets for planet hunters, as rocky planets orbiting these small stars can be more easily detected. However, there is a catch. M-dwarfs are significantly more active than our Sun and often flare and emit high-energy radiation, which could be harmful to potential extraterrestrial life or a planet's atmosphere. Previous observations of TRAPPIST-1b were not sensitive enough to rule out the possibility of an error. The planet's nature is a barren rock, as the planet is tidally locked to its star. One side is always facing the star, and the other is in perpetual darkness. As predicted by simulations, if TRAPPIST-1b had an atmosphere, the temperature of the planet would be lower because the air would distribute heat around both sides. However, the JWST measured a much higher temperature, ruling out the possibility of an atmosphere and eliminating another planet from the list of potentially habitable worlds. Nonetheless, what is exciting is not just about TRAPPIST-1b. It is the fact that the JWST can make such observations, allowing us to test the climates and temperatures of countless more worlds. What might life on these planets look like? The James Webb Space Telescope has decided to step into the role of an extraterrestrial meteorologist, engaging in some space exploration. The expensive piece of space technology has been used by a team of international astronomers hoping to harness its powers across the universe. It's the latest in a short but rich history of significant exploration, including taking snapshots of a nearby moon that looks eerily like Earth. This is just the beginning of its cosmic expedition. When it comes to weather, the Webb has been precisely studying what is happening on a giant planet nearly 280 light-years away, which was largely discovered by the Hubble Space Telescope in 2011. The weather forecasts have revealed temperatures of 1,250 degrees and tropical winds faster than 5,000 miles per hour, all concealed under thick high clouds covering the night side of the planet. The reason for this is that WASP-43b is tidally locked, meaning that while one side is continuously exposed to light from its nearest star, the other side, which has a clear sky, never experiences any light at all. By combining precise temperature measurements, the JWST continues to advance our understanding of weather patterns on distant planets. The James Webb Space Telescope's mission is far from over, as it embarks on an ongoing journey of discovery. Its advanced capabilities continue to provide groundbreaking insights into the cosmos, expanding our understanding of the universe in unprecedented ways. Among its latest achievements, the JWST has captured images and data that reveal both the complexity and the scale of the universe, contributing to our knowledge about everything from the formation of galaxies to the potential habitability of distant exoplanets. One of the telescope's significant contributions is its ability to observe the early universe. By looking at light that has traveled billions of years to reach us, the JWST allows scientists to peer back in time to the formative stages of cosmic history. This capability not only helps us understand how galaxies and other celestial objects formed, but also provides clues about the conditions that existed shortly after the Big Bang. Such insights are crucial for piecing together the evolution of the universe and the development of its most fundamental structures. In addition to its work on galaxy formation, the JWST is making strides in the study of exoplanets, particularly those that lie within the habitable zone of their parent stars. By analyzing the atmospheres of these exoplanets, scientists are looking for signs of potentially life-supporting conditions. The data collected by the JWST will help determine whether these planets have the right conditions for liquid water, a key ingredient for life as we know it. This research could significantly impact our search for extraterrestrial life and help us understand the potential for finding habitable worlds beyond our solar system. The telescope's ability to capture detailed images of distant celestial phenomena also provides valuable information about the physical processes that occur in space. For instance, the JWST's observations of supermassive black holes and their interactions with surrounding matter offer new perspectives on these enigmatic objects. By studying the growth and behavior of black holes, scientists can gain a better understanding of their role in galaxy formation and evolution. Moreover, the JWST's observations are helping to refine our knowledge of the distribution and properties of dark matter and dark energy. These elusive components of the universe are believed to make up a significant portion of its mass and energy, yet they remain largely mysterious. The telescope's ability to observe distant galaxies and other cosmic structures contributes to our efforts to unravel the mysteries of dark matter and dark energy. As the James Webb Space Telescope continues its mission, it will undoubtedly yield even more astonishing discoveries. Its advanced technology and observational capabilities are poised to transform our understanding of the universe and our place within it. With each new discovery, the JWST brings us closer to answering some of the most profound questions about the cosmos, including the potential for life beyond Earth and the fundamental nature of the universe itself.